This is the electricity homework booklet question 13. Again, potential divider question. We've got two resistors R1, R2 in series with a battery of 12 volt EMF, negligible internal resistance. The reading on the voltmeter is 8 volts, there's the voltmeter, it's across R1, and the resistance of R2 is 60. First thing we're asked to do is calculate the current in the circuit. Well, I know the PD across there, which would be fine if I knew what that resistance was, but I don't. So what I'm going to have to do is work out what the PD is across that resistance, use that with the value of that resistance R2 to work out the current. So the PD, if I've got 12 volts in total and the voltmeter is telling me that here I've got 8 volts, then V2, the PD across R2, is 12 minus 8 is 4 volts. Now I can do a V equals IR on R2. I is V upon R, 4 volts across R2, 60 ohms, 0.067 amps. Then asked to calculate the resistance of R1, and to me the simplest thing to do here would be to, again, do V equals IR, but specifically for R1 this time. R is V upon I. I've got 8 volts across R1, and I've got the same current as I had in R2 because it's a series circuit, 0.066, as many sixes as you want, 7, and that works out as 120 ohms. You could be clever here and you could say this is a potential divider between R1 and R2, and I've got twice the PD across R1 that I've got across R2, therefore it must be twice the resistance. R2 is 60 ohms, R1 must be 120 ohms. Just going back, part A, it was 1 mark for getting the PD, 1 mark for getting the current, is a single mark for working out that resistance in part 2. Got to calculate the charge passing through the battery in 20 minutes, giving an appropriate unit. That's just a Q equals IT or I equals delta Q upon delta T question using the current that we calculated back up in A part 1 multiplied by the 2 minutes multiplied by 60 to get into seconds, and that gets me to 8 coulombs. So what happens now is we replace R2 with a thermistor. We've got to state and explain what will happen to the reading on the voltmeter as the temperature of the thermistor rises. So it's R2 that's replaced with the thermistor. So that becomes the thermistor, and the temperature, as the temperature on that rises, a thermistor temperature rises, we get more electrons being released, we get a drop in resistance. If I get a drop in resistance there, that means I'm going to increase the current. If I increase the current through a fixed resistor R1, that's going to increase the PD. So the marks were for saying the resistance of the thermistor goes down, the current in the circuit goes up, and therefore the PD across R1 goes up. Again, you can use a potential divider argument. So as the resistance of the thermistor goes down, R1 becomes a bigger fraction of the total resistance, and therefore the PD across it is going to go up. That's the electricity homework booklet question 13.